Sink or swim. Captains of boats are always on the lookout for dangers in the water. After big storms, tree trunks weighing several tons can be found floating in the sea. If a ship collides with a floating tree trunk, the ship can be damaged. Logs and other large floating objects must be avoided by ships at sea. Some people think objects float because they are light, but a log floating at sea might have a mass of several tons. That's heavy. So why does the log float? The answer is density. Think about a block of wood in the shape of a cube, 10 centimeters on a side. If you weigh it, you might find that the block of wood has a mass of 500 grams. Now think about a block of lead exactly the same size and shape. Do you think it will weigh more or less than the block of wood? It will surely weigh more. The 10 centimeter cube of lead has a mass of about 11,000 grams. The two cubes are the same size or the same volume, but the cube of lead is much heavier because lead is much denser than wood. There is more matter in a given volume of lead than there is in the same volume of wood. Density is all about mass per volume. Now think about a 10 centimeter cube of water. If you could put the cube of water on a scale and weigh it, its mass would be 1,000 grams. Compare the three cubes. Wood, 500 grams. Water, 1,000 grams. Lead, 11,000 grams. The volume of a cube can be calculated by multiplying length by width by depth. In this case, all three cubes come out to be 10 by 10 by 10 centimeters, or 1,000 cubic centimeters, cc. If density is mass per volume, we can determine the density of any object for which we know the mass and volume. Just divide the mass by the volume. Wood, 500 grams divided by 1,000 cc's equals 0.5 grams per cubic centimeter. Water, 1,000 grams divided by 1,000 cubic centimeters equals 1 gram per cubic centimeter. Lead equals 11,000 grams divided by 1,000 cubic centimeters equals 11 grams per cubic centimeter. Here's one of the big ideas behind why things float or sink. If an object is less dense than water, it will float in the water. If an object is denser than water, it will sink. It's that simple. A common science activity is to make paper cup boats out of a kind of paper that has a density of about 1.1 grams per cubic centimeter. Because the paper is denser than water, it should sink. But when you put a paper cup boat into water carefully, it floats. And it will carry a load of penny passengers too. How is this possible? Paper, steel, concrete, and even lead boats float because of their shapes. Boats have large air spaces inside. Air is not very dense at all. The boat should be thought of as a system made out of two materials, which are a dense hull and a not very dense volume of air inside. The end result is that a boat filled with air is a system that is much less dense than water, so it floats. As passengers, pennies, are added to the system, the density of the system starts to change. With each added penny, the boat settles deeper into the water. Eventually, the boat air passengers system will reach a density of 1.0, which is the density of water. Pure water always has a density of 1.0. One additional passenger will make the boat system denser than water, and down it goes. What variable determines the number of passengers a boat will hold? Its volume will tell you. The bigger the boat, the more air it has included in this system. A boat can hold a lot of pennies if it contains a large volume of low-density air. Think about this interesting experiment. 4 students in Tampa, Florida, got some float and sink materials together. Here are what they gathered and the density of each material. Material, density. A piece of wood, 0.5 grams per cubic centimeter. A piece of wax, 0.9 grams per cubic centimeter. A piece of ice, 0.9 grams per cubic centimeter. A piece of tar, 1.0 grams per cubic centimeter. A piece of plastic, 1.1 grams per cubic centimeter. A piece of rubber, 1.2 grams per cubic centimeter. A piece of copper, 9.0 grams per cubic centimeter. What do you think the students observed when they put each material in water? Make a list of your predictions on a separate piece of paper. The Tampa students had another idea. They made a saturated salt solution. The density of the saturated salt solution was 1.2 grams per cubic centimeter. They put their objects in the salt water. Do you think they got the same results, or would you expect different results? Write down your predictions and compare them with those of other students.